Today we are going to prove that the derivative of tan x is secant x squared. Now, in the former videos, we proved the derivatives of sine and cosine. We proved the derivatives of sine and cosine, and we found that they are, I'm going to just write it down real quick, dy dx of sine x is cosine x, and we found that dy dx of cosine x is negative sine x, and we derived that by plugging them into the original differentiation formula. But now that we have these, we don't need to do that for every one of the trig functions, because every other trig function is going to be somehow differentiable. Because we already have these, we can use them to help. So we don't have to do the long hard way with the other ones, we can just use these. I'm going to show you what I mean with tan x. Because as you probably remember, tan x has a trig identity. It has many trig identities. There's a lot of different trig identities, but tan x specifically is sine x over cosine x. That's just one of the trig identities, one of the simpler ones, actually. Okay, well, that makes our life pretty easy because we know the derivatives of sine and cosine, and we know tan is sine over cosine. So how are we going to derive tan x? We're just going to plug in sine and cosine. We know that tan x, let me just change colors. Okay. We know that this is going to be dy dx of sine x over cosine x. Well, that makes life a lot easier. It doesn't make it completely easy because we still have to apply the quotient rule, but it makes it a lot easier. So now what we're going to do is we're going to just apply the quotient rule. Let me just write that down really quickly. Apply the quotient rule. And if you remember the quotient rule, I'll write it up here. The quotient rule is that f over g prime of x is g squared in the denominator, and then g times f prime minus f times g prime. Okay, and the easiest way to remember that, my professor taught me this trick, is to look at the denominator. Remember that the denominator is going to be the first argument in the numerator, and then the rest of it just comes more easily. Okay, so now we are going to just apply that. We're going to apply that to sine x for cosine x. So sine x is f, and cosine x is g. So this is going to equal. Okay, let me write the denominator first. So that just makes life easier. This is going to equal cosine x squared. And then we're going to multiply cosine x by sine x prime, and subtract sine x times cosine x prime. Well, we know what both of those are because we have them up here. So we know that we are just going to get cosine x times cosine x. So that's cosine x times cosine x minus sine x times negative sine x over cosine x squared. Well, okay, now we have cosine x squared over cosine x squared minus sine x squared, plus sine x squared over cosine x squared. Well, what are we going to do? How are we going to simplify this? We're just gonna write that out and see if we can maybe identify a trig identity to help solve this, right? So we're going to have cosine x squared minus sine plus sine x squared, because these negatives become a positive, sine x squared over cosine x squared. Well, cosine x squared plus sine x squared equals 1. We have that video, I'll link it below at the end of the video, in which we showed why cosine x squared plus sine x squared equals 1. It's the first Pythagorean trig identity, actually. Let me just write it down over here. Cosine x squared. It's actually cosine theta, but it doesn't matter what the variable is. In the former video, we used theta, but here it's x. It's the same exact thing, though. Cosine x squared plus sine x squared equals 1. And the reason for that is just that we plug in x and y on the unit circle into the unit circle formula, x squared plus y squared equals 1, because on a unit circle, cosine x and sine x are x and y. So it's not too hard. You just have to sort of learn to see these things when you look at this. This is actually going to, so this is going to become, I'm actually going to start writing tan x prime to make my life easier. Tan x prime, so tan x prime equals 1 over cosine x squared. Well, that equals 1 over cosine x squared, right? Cosine x squared. Oh, I accidentally wrote the square twice. Let's not make that mistake. Cosine x squared. Well, what does that equal? 1 over cosine x actually equals secant x. So we actually have secant x squared. So our solution, our final solution, I'm going to write it in the notation where the square comes before the x, just because I prefer that notation. So our solution, and the end of our proof is that dy dx of tan x does indeed equal secant x squared.